Hello.
Man, there's a lot of people here. All right. Welcome to Engineering Shadow Day 2021. Normally we would have this event live on campus. Unfortunately, we can't do that this year. So we decided to host a Q&A with a couple panels of people from Wilkes University for the prospective students to come and join and ask any questions that you might have. So the first panel that we have tonight is going to be the faculty. So to start off the night, I'll just say we are recording this meeting for anybody that's just for everybody to know. If you don't want to be shown in the video, I think the plan is to share the video with any other students that might want to view it in the future. Feel free to hide your video, that's fine. We'd also ask that you follow our Wilkes University ESAC Instagram profile. It's written there, it's Wilkes U_ESAC, ESAC. We are planning on doing a giveaway. We have some t-shirts that we're going to give away. So if any of the students who are attending would like to follow our Instagram profile, please feel free to follow that. And then we will reach out to you and coordinate with, we'll just randomly select 2 people to send a t-shirt to. And then we have some emails there. If you'd like to write them down, or we can send them out in an email after the event. The first one is Nikki. She's our administrative assistant with Professor Taylor in our electrical engineering department. She helps us run the club. And then I'm listed there as, that's me, Spencer Yakubowski. And then Sarah and Olivia are also in the club. So with that, I think we can start the panel. We're gonna have the panelists give a short introduction of themselves. And then after that, we're going to go into questions. So if you could please give your questions into the chat. I think you can chat to everybody in Zoom, and then we will go through the chat and relay your questions to the panelists and hopefully get everybody's questions answered, and hopefully get some good information about Wilkes. So with that, I think that we can start our first panel. I'll stop sharing here. Also, if you change your view to speaker view in the top right corner, that'll highlight who's speaking. So with that, I think we can start our panel. So I think we can start. Dr. Troy, would you like to go first?
Yeah, sure. Good evening, everybody, and welcome. It's nice to be with you. My name is Marlene Troy. I'm a professor of environmental engineering. I've been at Wilkes, I was counting 24 years now. Hard to believe that time goes by. My background is in hazardous waste management, so I teach the waste management courses, and I'm also involved in environmental sustainability quite a bit. So I'm doing more of that, which is more interdisciplinary. We have a great program we're going to be launching. We have the environmental engineering program, and we're going to be launching a civil engineering program this fall that we're excited about. And we have a great program, very much hands-on, all the challenges that we're facing. And we look forward to, answering any questions and hopefully seeing you here in the fall.
Awesome. I'll just go left to right on my screen. I think Dr. B, you're up next.
Great, thanks, Spencer. My name is Dr. Edward Bednars. I'm an associate professor of the mechanical engineering department. I actually came to Wilkes in 1997 as a student, so I graduated 20 years ago, and now I've been back as a full-time faculty since 2013. My specialty is engineering design, so you're actually going to hear from a lot of my students later on throughout the session because I'm the co-op coordinator, that's the internships for credit, as well as the senior projects instructor in the mechanical engineering department. So you're going to get to hear from a lot of my students throughout the night. So thank you, Spencer.
All right, Dr. Baddour.
Hi, everyone. I'm Carol Badour. I'm an assistant professor in mechanical engineering. This is my 4th year in the department. My specialty is in nanomaterials. I'm the co-advisor for the Wilkes chapter of the Society of Women's Engineers, so SWE, and I'm the ABET coordinator. So for accreditation of our department, I help work on that as well. So it's great to see everyone tonight, and we hope to be able to answer your questions. Thank you.
All right, Dr. Shaw.
Hello, everyone. My name is Shisha. I joined Wilkes University in fall 2018. Majorly, I'm teaching the digital related class, digital design, C programming, and embedded programming, embedded system design. And right now, I'm serving as the IEEE student branch counselor at Wilkes University. If you have any question, please feel free to ask. Thank you.
All right, Dr. Carney.
Hello, everyone. My name is Sarita Karne. I'm an assistant professor in the Department of Environmental Engineering and Earth Sciences. This is my 3rd year. I'm also a new faculty member. It's exciting to be here at Wilkes and see the program completely different from where I went to grad school. My research focus is air quality, and I'm sure all of you must be more interested now in terms of air quality with COVID, considering you're spending more times indoors. So hope to see some of you in classes. And I'm also the faculty advisor for the Air and Waste Management Wilkes student chapter. Thank you.
Awesome. And Professor Taylor, since we've got you here, you could give a brief introduction as well.
All right. Good evening, everyone. I'm certainly glad you're here. My name's Bob Taylor. I'm the chair of the Electrical Engineering and Physics Department. My background is 40 years in industry and aerospace and the nuclear industry. And I'm the faculty of practice fundamentally in engineering management, where my expertise is primarily in project management, project risk, and new product analysis. Certainly glad you're here because I am the faculty advisor for the ESAC, and I also am faculty advisor for our senior projects and our electrical engineering co-ops and interns. So if you have any of those questions, we'd certainly like to help you out, and personally invite you to come to our campus when you can and come in and see us all. So thank you.
Awesome. So those are the 6 faculty I think we've got for the panel to start us off for our first half hour. I saw a bunch of you joined into the room about midway through our introductions. So again, just if you've got any questions, feel free to type them into the chat and we'll be sure to relay them to the faculty to get them answered. So we have a bunch of some questions to start you off with. So the first question I think that I can ask, and then you can, if you have an answer, feel free to chime in. So how, as a student at Wilkes, can I get help from my professor outside of office hours in cases where I cannot attend them?
I think it's one of our hallmarks of Wilkes to have caring faculty. And I know it sounds very corny and cliche to say that, but you know, myself and all my colleagues, everyone represented here and everyone else that's not here tonight that you'll meet in the fall, we truly do take pride in getting to know our students, learn their names, help them out. We're always available via email or in our office. Spencer, I was trying to listen to your question. You said, how are we available outside of normal office hours? Yeah, I think of us make especially now, right now, I'm kind of working all virtual, working from home. I'm meeting with a student tomorrow at 5 p.m. and then Saturday at 11 via Zoom. You know, so actually technology is helping our availability even more than just having to try to find your professor in their office. So yeah, I think a lot of professors just reach out via email and definitely get back to you. So
I think the Zoom is really impacted a lot or made it a lot easier to do connecting with everybody's crazy schedules.
Yeah, and one thing I'd say from my experience on Wilkes too, it seems like all of our professors have an open door policy. If their door is open and they're not busy, you can walk right in.
I was going to say that most of us have open door policy, and you could email us now, like Dr. Troy and Dr. Bernard said, now with the Zoom, you could even, we're trying to set up meetings over the weekends and even at 8 p.m. trying to go over senior projects with students. So I think in that point, we are very open to helping students and much more friendlier, or I guess more accepting, or I don't know, good word, but.
I think the way oh, go ahead, Carol.
Talking too fast. I'm sorry. I was just going to say the key thing is to just let us know that you need help. We're not mind readers. So as long as you reach out to us in some shape or form and let us know you need help, then you will get the help. So
I think that once I get to know many of the students, I just go ahead and offer my cell phone. And the only rule I demand is that you better send me a text first, and then you can call me, because if I'm unavailable and I don't get a text message in advance, I probably won't answer your phone call. But the bottom line is we're here for the students, and many of us are here at some very unusual hours. We've had students come in at 10 o'clock at night on a Thursday night and have a problem with a physics lab, and our physics instructor was here. And so we're here to help out. We can meet you at almost any hour you want to come in. Just the key is we want you to reach out sometimes. And if it's hard to reach out to us, it's go see some of the students that know us better. This Wilkes is a family, the student family. We get together a lot. We know each other. We know how to help you. And I think you'll find that, as already mentioned, we do have open door policy, but it's kind of an open door for all the time. It's just reach out. We're here to help.
Yeah, and I'd like to point out that Professor Taylor is in fact in his office right now at 6:30. I think he teaches later classes, but yeah, he's usually there till 7. I can't see everybody's background, but I'm sure there's more than just him on campus right now. So it's never hard to get a hold of a professor at Wilkes.
Even if they're not your teacher, like Bob Taylor is my advisor, and I'm in his office probably every week just to talk to him. Me and Olivia go in there just to have a conversation.
Yep. All right, so then another question for our faculty panel would be, are students able to help in research led by you? Can it be done during the semester or during break?
Yes, and I would say both, and just let us know. I've had students get involved with research in their freshman year all the way up to their senior year. And we also have the summer mentoring program that we encourage students, and actually we were able to hold it last year, even in the pandemic. We did it some projects virtually. So see, yeah, whatever you're interested in here, we're always looking for energy. So anybody that wants to help is more than welcome.
Yes, for the student research, we have a bunch of topics that offer to undergraduate student and fit the undergraduate student background. And in these topics, the student will do some experiment, either in the both in the semester or after the semester in summer or in winter holidays. And the faculties are usually available to help students with some guidance or fill in some gaps in the technical details.
Yeah, I think including undergraduates in our research is key, and it's something that we welcome. And I know currently I have students in an independent study course, so that's one avenue that they can actually get credit while performing research with faculty members. So that's one option. But yeah, I definitely welcome any undergraduate that wants to get involved in research and try to mentor them the best I can.
There are definitely many opportunities out there. The key thing is, again, talk to us about it. So I have, right now, I'm working with an undergraduate student that I've known since he's a junior now. I've known him since he's a sophomore. We're working on nanomaterials in my lab, and he's very active in the research that we're doing this semester. And it all started with a conversation in class. It was in statics class, and he reached out to me and he started talking to me about some interest that he has. And it went from there. So the opportunities are definitely out there for undergraduate to do research with us.
That's true. I would say you have to reach out. Either you reach out to the faculty members during the class time or after the class time, or to your advisor. You can go to your advisor always and ask, I'm interested in doing research, but I don't know what kind of research the faculty are doing, and they can help you guide or give you information who's doing what. So you could approach them. I also have a student who's currently working on a project with me, trying to set up some monitoring sensors and meteorological sensors to do some monitoring, air monitoring around Wilkes-Barre area. And I'm hoping to work over the summer with a mentoring grant with a couple of students on other projects. So it's just, you have to approach, like Dr. Bador said, we're not mind readers. You have to approach us. There's a saying in my language that even mother doesn't know that you're hungry unless you tell her she's not going to offer you food or feed you. So I guess, so you just have to approach and make sure you find information, or if you cannot find relevant information from that professor, go to somebody else and someone is going to help you. It's just approaching them, but don't wait till last minute also if you need help with the classes and stuff. Don't come the day before the exam and say, hey, I cannot understand this. That's going to be difficult to teach the whole material in one day. But research is the key focus. Yes.
We have a question from one of our students. Do you declare your major right away as an engineer, or is it sometimes later, like after freshman year?
Well, I'll start with that one. Quite frankly, I don't know many engineers that knew exactly what they wanted to be the day they walked into college. Most of us had a hard time making our minds up. And I think that the answer to your question is, normally, while we might recommend that you pick a major so you can get with an advisor, just kind of pick a major you might like, the answer is you don't have to pick your major when you first come. With engineering, though, it's better to try to get it done during that first year. About the first semester of your sophomore year is about as late as you possibly can wait to declare a major. And the prime reason for that is that you're going to find out that course information and content in upper level courses rely heavily on a previous course. So your freshman year, you're going to be taking a lot of common courses. And the good news is you'll be able to see a lot of different kinds of engineering, and you can talk to professors before you make a final move. But I think the sooner you do it, the better off you are. But it's not a crisis to say, I'm going to start day one as an ME or an EE or environmental engineer or civil engineer. You can wait a little bit.
Yeah, and I think that our curriculum, if I'm not mistaken, the first 3 semesters are almost entirely concurrent between, I know, at least mechanical and electrical engineering, and I think a lot of environmental as well. So yeah, it's not imperative that first semester to know.
I think just kind of piggybacking off of what Professor Taylor said, you probably should go into engineering if you know you want to be engineering. It's probably hard, taking the question literally, you probably can't start from a art major and then easily transition to engineering. But if you think, yeah, engineering is my field, but I don't know if I want mechanical, electrical, environmental, civil, like Spencer and Professor Taylor said, the first 3 semesters are common. You really don't have to declare the specific, but I think if you know engineering, you probably want to get in the engineering path right off the bat.
We have another question. What type of courses will we have to take as a freshman?
Dr. B has a fun one, right? Don't you teach an FYF class with Legos or something like that?
I do, yeah. So pretty much the standard curriculum is you want to take your calculus, chemistry, CAD, English is a requirement right off the bat. So, there's a lot of just I like to hearken engineering curriculum as learning to ride a bike. You know, you need the fundamentals first. You learn how to, okay, I have to stay stable and I have to get going. But then when you get further into the curriculum, then you get to do the cool designs and innovation and creativity. You know, by your junior, senior year, you're actually designing your own things, building them, 3D printing them, putting them together. So what, you know, going what Spencer said, I tried to create a freshman level course. It's FYF 101. It's a required course that all students have to take, FYF 101, but then there's specific topics. There's 15 different topics. So I offer just one section of engineering design to try to get students exposed to what is engineering as a career, you know, as you go on. But and I think environmental may have a section as well, Dr. Troy.
We've rotated through that, but yeah, we've done something similar as well. So I think all the fields have done something similar.
Right.
And as I said, you take the core, like you said, the foundation or the backbone courses, and then it kind of leads up to the things you want to specialize in or are more interested in, that you've got the good, strong foundation.
Yeah, and I know I took my FYF in like global travel or something like that. So there's a wide variety of those courses that you can take. And then the engineering curriculum is very similar for every major over the first year. So yeah, that first year is your basics, like Dr. Bednar said, calculus and things like that.
We have another question from Bobby. If you start as an undeclared engineering major, will the classes be a combination of general courses as well as overall engineering courses?
I'd say they're going to be the same core courses. It's still going to be, for general engineers, it would be the, you know, the math, the chemistry, and you know, the humanities requirements that you're getting out of the way. The CAD is common to all engineers. So pretty much that first year, it's the same no matter what engineering major you are. So even if you haven't selected a major, it's still pretty much the same course sequence. So you really don't lose any time. But like everybody has been saying, the sooner you can decide by your sophomore year is when you have to start specializing or taking the electives in your major, the required courses in your major.
Liz or Spencer, can I have, can I just share my screen quickly? I could bring up the kind of the flow chart.
Yeah, Liz, I think Liz can let you share your screen.
I just made you a co-host.
Yeah. All right, so here's kind of for the mechanical engineering curriculum, but pay attention to the first 3 semesters because they're the ones that are going to be common for most engineering majors, ME, EE, environmental, civil. You know, as we mentioned, you're going to have your CAD, chemistry for engineers, calculus, English composition, the FYF course. Then it moves into calculus 2, physics, material science, programming. Then the 3rd semester, physics 2, differential equations, circuit theory, statics, gen ed. So these first 3 semesters are really the common ones. And then as Professor Taylor said, the 4th one this is where it breaks out. And I'm showing kind of the specifics for the ME curriculum, strength materials, dynamics, thermodynamics, you know, and then the other majors would have their own specifics at that point. So.
Yeah, the environmental is pretty much the same. It's just that 2nd semester we have a different elective, but it can count for other programs. So that's not a big deal if you took another one to going back. But other than that, it's pretty close. And the environmentals are not required to take the electrical. So we have some other courses. So once again, it's not hard to switch back and forth. But pretty much by your sophomore year, you want to have a good idea of what engineering field you want to study.
Yeah, and I think if you leave your screen there for another second, Dr. B, if you see that 3rd semester, there's general education. The way that Wilkes structures the like the gen eds and the humanities requirements for your major, you have what's called, I think when I started, they were called distribution requirements. I'm not sure if they still use that term, but you can find a list of them on the website, and they're a common group of about 30 credits that every student at Wilkes has to take. And if you come in undeclared, you would probably just take a lot of those at the beginning. I know I did dual enrollment when I came to Wilkes, and I started out and I did a bunch of those credits right in the beginning of my education. So by the time you get to your 6th and 7th semester, I didn't have to fulfill those requirements anymore. But I'm pretty sure in the engineering curriculum, it's like pre-prescribed what semesters you take your gen eds. And those are electives that you choose of the list that they provide you. So yeah. I think I saw a question. Yes, Sarah already answered that from Joseph. Yeah, we'll ask that question in the next panel. I think we have a couple of student athletes coming in the next panel. Any more questions? Feel free to post them in the chat. We've got like, yeah.
What's your favorite class to teach?
Yes.
I'll bite. One of my favorite classes, quite frankly, is senior projects. And the other is, it's very closely related to new product development. How do we take technology and how do we get that into the marketplace? How do we do cool things with engineering, design projects that are new and different? Those are my favorites.
I like a sophomore level class. It's called Strength and Materials. It's a 4th semester class. And the reason I like that one the most is that's the one I took as an undergrad that made me solidify that I wanted to go into mechanical engineering. That's when you're calculating stress and strains and deflection on structures. I'm like, wow, this is all really cool stuff. You know, this is, and then I could extrapolate. You're going to go and design things that'll be under loads and not break. So yeah, it's ME 232 Strength and Materials. That's my favorite.
Yes, for me, EE 241 is my favorite class that is for the digital design. And this semester, Sarah and Olivia and Rachel are with me.
I have my circuit right here, Dr. Shah.
Yes, that's what we build. And we start from fundamental logic principles, and then we move to the 74 logic component, and we have the labs. And in the next, after the midterm exam, we are going to have the VHDL on programming on the FPGA. So this is a pretty comprehensive practice in the logic design field, and it opens a new field in the computer related area for us.
I think that we can finish this segment up with one last question from the chat from Andrew. Asks, what is the ratio of time that is spent on lectures compared to hands-on work during your classes?
I think I'd like to start off on that. Andrew, to answer your question, most of the environmental classes have a lab component associated. So you're pretty much spending equal amount of time in the lab and in the lecture. And even for a freshman class, which is microbiology this semester, we try to incorporate an experiment, at least for one day. So that way you get a feel for the lab component, or actually see through the experiment or learn through the experiment and not just by the lecture. So every possible time we try to include experiments and hands-on things. So that's one strong point I feel at Wilkes. With getting education from a different location, I can say that's very strong point with Wilkes University. You get hands-on, equal hands-on experience with the material or the experiments and equipment.
Yeah, and all the engineering majors have to do the capstone project, so you're spending a year-long effort with a team of students working on solving an engineering problem or designing a technology. So you get a lot of hands-on experience in that venue as well.
A lot of our courses are structured so that there is a 3-credit lecture course and an accompanying 1-credit lab course. I know in our department we have fluid mechanics, heat transfer, mechanical design, mechatronics. You know, there's a whole bunch of courses, and I know the other departments have similar. So yeah, we try to have a good balance of learning the theory and doing the calculations, but then also getting hands-on, doing the experiments yourself, knowing how to write lab reports and reporting data and analyzing and understanding it, but also building the projects, like Dr. Troy said, the senior capstone projects is a great way to get hands-on as well.
All right, and I think that with that, we'll bring a conclusion to our faculty panel. I'd like to thank the 6 of you for answering all of our questions. So with that, I think that we'll move on to the second segment that we have planned for you all with our student panel. So just to reiterate, we're going to start off with some short spoken introductions from our students, and then we will move into a segment of time where we'll let you ask your questions in the chat, and we will ask them of the panelists. So I think that we have 5 students. I think I saw everybody here, right?
We have Kayla, Brian, Rachel, Olivia, me, and you.
I think Rich is here, and I think Alex was supposed to hop into. I don't know.
I don't know where he went.
That might be him. All right.
I'm here.
Okay, cool.
All right.
All right, so I think we'll start off with our introductions. Rachel, if you'd like to give us a short introduction, and then we'll move on.
Okay, my name is Rachel Meniscus. I'm currently a senior in the electrical engineering program here at Wilkes. I'm actually a transfer student, so I came in last year, like starting my first year. I actually came over from King's in like the physics program. And I guess that's about it.
All right, Brian, if you'd like to go next.
Hi, my name is Brian Gallagher, and I'm a junior environmental engineer, and I'm minoring in geology as well. And I also play soccer here, so I don't know if there's any of the students that are incoming that want to play a sport, but I could help and answer some of those questions, how to balance time and stuff like that.
Awesome. Kayla?
Hi guys, my name is Kayla. I am a senior environmental engineering student with a minor in sustainability management. I am president of the school's chapter of Society of Women Engineers as well.
Awesome. Rich?
Yeah, I think I clicked off the video, hit the wrong button there. Hey guys, I'm Rich Sapkowski. I'm going for my master's in mechanical engineering, and I previously graduated with my bachelor's in mechanical engineering last year, and I got minors in engineering management and physics, and I was also president of ASME.
Cool, I'm seeing a lot of answers to questions that have already been asked. Alex?
Hi, I'm Alex. I'm a senior mechanical engineering student, and I have minors in computer science, mathematics, and physics.
And then I'm Spencer Yakubeski. I think I introduced myself at the beginning. I'm a senior at Wilkes, double majoring in mechanical and electrical engineering. And then if Sarah and Olivia, you guys want to introduce yourselves as well?
I'm Sarah. I'm the vice president of ESAC. I'm majoring in electrical engineering and minoring in computer science and computer engineering. So I could answer the question about the minors.
I'm Olivia. I'm a sophomore. I am in electrical. I'm going to go into mechanical next year and do a double major of electrical and mechanical. And I play volleyball. Yeah, that's about it.
Awesome. So I think that the first question we had last that was we said we'd answer in this panel.
How to balance student and athlete life.
Yeah, so Joseph asks, how do you balance your life as a student athlete?
Should I take that one or?
Sure, yeah, feel free to jump in.
All right. Well, I mean, it is a lot trying to balance everything like that, but I think there's definitely a lot of sacrifices that you have to make. I know sometimes you gotta not nap. I think that's a big one. If you have that free time to not nap, but to actually get into your school, go into your schoolwork from there, and then, but also like kind of plan out your week as you go. So like kind of write down everything that you have. So it's like, I have homework due on Monday or Wednesday or Friday or whatever. I have an exam Thursday or however it is, but I also have practice on these days. So you can look at your schedule. If you make a schedule for the rest of the week, you can be like, all right, so I can do this assignment during this time period. I can do this assignment during that time period. And it also helps if you have like other friends that are in that in that same major with you, so you can go through with them if they're on the same team as you. But I think my main way that I help balance it is definitely planning out my week. So like I could be like, all right, so this is when I'm gonna get this assignment done. And this is when like just plan out your week accordingly with what you have for the sport and everything like that.
All right, so our next question was, do students have enough time to get a minor or two along with majoring in engineering? That was from Nicholas. As I said, I have 2 minors, so you 100% can do it. I also started before I got to Wilkes. I took classes in high school, and I also took classes over this winter semester, but you could 100% do a minor and your major all in one.
And I think that Nicholas also added on to his question and asked, is it possible to do a minor while majoring in engineering and also playing in a sport?
Yeah, that's what I'm doing as well. But I was lucky with some of my classes for my minor kind of overlapped. So I already had credits towards my minor as I was going towards it. But that I do believe that it is possible to do that.
And I know, Rich, I think you said you had a minor in physics. That's not much on top of your mechanical degree, right?
No, I have a minor in physics and engineering management, and it was just a couple extra classes. So for some of the free electives, I just chose to do something with the minor. So it pretty much fit right into the curriculum.
Yeah, and I know that a physics major too, on top of like if you're an electrical engineer at Wilkes, to get a physics major is 3 more courses and senior projects, and a minor in physics is, I think, 1 course. So you get to take a higher level physics course to add on to your education at Wilkes, and that provides you with a minor.
I believe that's the same with mathematics. You only need 1 more course upon your engineering courses to have a minor in mathematics too.
Yeah.
You need 2 more courses in math. You need 200-300 levels, but yeah.
Yeah, so 2 courses, it's not terrible to find time, especially if they have a generous offering of summer and winter courses as well that you can take. So if you're interested in doing that, you can definitely do that.
We have another question. What led you to study a major in engineering? Anyone want to take that one?
I mean, I just found that I was like happened to be decent at math in high school, and I kind of figured I wanted to do something with that. And personally, for me, I did not want to be a mathematics major, so I guess engineering was kind of the next best thing for me.
I love math. The reason I went into electrical engineering is because my father actually went to Wilkes and graduated with his master's in electrical engineering under one of the teachers that are currently still here. He could not make it tonight though, but he was my main factor in coming to Wilkes and going into electrical.
So I would say at Wilkes, a lot of the mechanical engineering students are car guys, if you will. And so we have a large ASME is one of our clubs. I think it's American Society of Mechanical Engineers, right, Rich?
That is correct. Good guess.
And they host a car show every year. That's a really, really cool event. Rich basically ran it for probably 5 years, even though he's only here for 4. And yeah, so that's, I think, a big influencing factor of why a lot of mechanical engineers choose to study engineering. For me, that's what introduced me to engineering. But then when I got here, I ended up taking electrical engineering at the advice of Professor Taylor. And I had Dr. Shaw in class too. And once you get here, I wanted to be a mechanical engineer, but ended up liking electrical more. And that's actually more what my job is going to be focused on next year. So it just evolved since I got here.
I know for me, I decided originally I was more interested in like doing something like art related. But my mom signed me up for like some STEM camps or something, and I found out I was good at doing, I guess, engineering types of things. And I always had a passion for saving the environment. So why not combine both? You know, I'm good at engineering and also I want to save the environment and combine them both into one major.
Awesome. And then I think the next question is from Andrew. Is it harder doing a dual major instead of doing a major and a minor and doing the extra courses to get the extra degree? So if I was going to speak to that, I would say it depends on what you're doing. So if you're doing a mechanical and electrical engineering dual major, I think a lot of the extra, it is a little extra work. I think it's an extra 20 some credits. So some students find it hard to fit it in 4 years unless they do a lot of summer work. So for me, I took classes in my senior year of high school, so that's I had a bit of a jump start. But if you look at the curriculum for electrical engineering and physics, like I said earlier, it's only a couple extra classes to get the physics major on top of that. But like Rich did, I think a lot of students also do an engineering management minor, which is a couple extra courses in business and business law. And I think one of them is a financial course, and that's Professor Taylor's wheelhouse. But yeah, it depends on what majors you want to do. I don't really know. I think it's worth it. I've enjoyed it, and it certainly helps in the workplace. You definitely enjoy, like, get a lot out of the experience of electrical and mechanical engineering combined. I don't know environmental wise how minors weave in with those degrees though.
Personally, for my minor, it's only an additional 4 classes in their online classes. So it's super easy to kind of, and I can use those classes as my electives for my major. So it's super easy to kind of fit them in whenever I have any extra space in my schedule. And since they're not meeting in person, I can kind of take the class at my own pace, as, I can either, do all the work in 1 week or kind of just take my time and spread it out throughout the course of the semester.
So I think that Andrew said in the chat he was planning on doing mechanical engineering and computer science. Alex, did you take classes in computer science?
Yeah, that's one of my minors. Yeah. Fun.
So how has that experience been?
Fun. Really helps out with, like, you have to take robotics later on and stuff like that. Really helps out a lot, knowing how to program and everything like that. As technology and all this stuff advances, I think you're going to see a lot of crossover between either PLC programming or some sort of programming and the mechanical engineering field. I think there's going to be a lot of crossover in the near future. But yeah.
And then we just got 2 questions. What types of jobs do you hope to get when you graduate? And do you guys have internships lined up? So we could touch on this quickly here. And then we have another panel at 7 talking strictly about that and our senior projects. But yeah, if you guys want to touch on any internships you've had, feel free to do that.
I've been an intern in the industrial park for over a year now at Cornell Cookson. I'm a strategic manufacturing engineer, but yeah, it's been great. They like me enough to keep me on for the whole year. So
I actually have an interview on Tuesday at the Allen P. Kirby Center for an internship. So I'm a sophomore, so normally going into your junior year is when you normally like get your internships, and that's when I'm going to my junior year next semester. So hopefully I get into that.
I also have one for the summer. I had it for the summer last year, but because of COVID, it got canceled. But I've yet to really see what I'm supposed to do. But during my interview, they told me I'd be working with like AutoCAD and stuff like that. So that's what I guess I would have been doing over the summer last year.
Yeah, and Wilkes has a very active career center, and there's a career fair every year. When it's in person, it's been a great event. Even last year, I think it was pretty good in the virtual space. It's been tough in the virtual space, but when it's in person, yeah, I think we have something like 100 employers show up and a bunch of grad schools. So if you're worried about internships, I would not worry that hard, because if you try to get one, you very well are going to line one up for yourself. So that's not been an issue at Wilkes by any means. I think Matthew asked, what made Wilkes your #1 choice?
I think for me, when I was deciding, one of the biggest things was when we got to sit down and talk to some of the professors. Just being able to talk to them and just begin to know what they were like right from the beginning kind of drew me in. Like, for instance, Professor Taylor, I know I sat down with him at one point. He had a meeting with me and he kind of explained the programs and things like that. And there was a good connection there between, me and a lot of the professors there right from the beginning.
For me, it was one of the very few like Division III schools where you can both play a sport and get a good education in engineering. And also one of the things I did like, and touch on what Rich said, I'm like, especially now that I'm a junior, like I could be walking down the hallways and see a professor and say hi, and they know me by my name and I know them by their name. So it's kind of like intimate there, like where you have a relationship with your professors and they know who you are, and I think that makes it easier for you to learn.
I mean, I think for me is I'm kind of from around the area here, so it was big for me to stay close to home, and I really like the fact that Wilkes is ABET accredited, which was something that was very important in my decision process.
Yeah. I think our next question is from Aiden. Are there any study abroad programs for engineering? I don't know that any of us have done that. I don't know if Liz knows anything on that as well.
I can jump in. Oops.
Perfect, go for it.
We had an electrical engineer, or no, I'll take that back. I believe it was a mechanical engineer about 4 years ago that wound up going over to the United Kingdom. And what we did was set up some courses. It's often unusual to see an engineer go to England and study engineering there, especially because most of our courses, or many of them, have been face-to-face courses. With the COVID, it has asked us and forced us in a way to take a little more strategic view of coursework and try to fit some of the lecture and discussion courses into an online format. And we've in fact done some labs in an online format. So the answer to your question is it's possible. And I believe it's easier today than it was a few years ago. But we made it work a few years ago, and I think we can make it work. It's completely up to you and how you'd like to do it, where you would like to go. But it's a very interesting item. I think with the world seems to be getting smaller, and Zoom, of course, is helping that. And so we have to be a little more flexible on those things, and I think it's possible. I think it was an exciting time. The student came back, was very excited about being able to study remotely with me and some of the things that I did, as well as find a couple of engineering courses over there. So I think it's possible.
Yeah,
go ahead.
To add something, yeah, Fred's another option too is that we do have like intercession programs to do study abroad as well. So maybe it could be over the summer for a couple of weeks or during a spring break or a winter break program. There's definitely options. Maybe if it doesn't work out in your regular semester, there are definitely other options to get involved into a study abroad program for sure.
Awesome. And Nikki said to ask if she said to ask if the environmental has a study abroad. Dr. Troy, do you have?
Yeah, I was going to say we had a student also go to University of Birmingham. This was pre-COVID, and took courses that we were able to find comparable ones for them to take that they transferred back here, and they had a great experience. And also, we've recently had a partnership with a university in Panama that we've had several of their students come up here, and then one summer some of our students went down there, and we're hoping to pick that up again once things settle down as well. So we had a great experience that way. So the answer is yes. It just takes some planning, but and there is a study abroad office and a coordinator that can work with you to plan this. So yes is the answer.
Awesome. Sydney asked, if any of us are in the honors program. If so, what are the advantages you've had with that program? Is anybody in the honors program?
I know one of my friends, she's supposed to be here tonight. Her name's Melanie. She's an environmental engineer. She's in the honors program and she absolutely loves it. I know that they do have a lot of extra work to do, but she is excelling in everything. And I could give you her information if you wanted. Maybe you could ask her some questions. She would be happy to answer them.
Yeah, I know that they have some specific courses. So their gen eds are like honors. I think their gen eds are honors specific. But yeah, I don't know much about the benefits other than that. And then we have a question for Rachel. How was the transfer process into the engineering program? Will you be graduating on time?
Honestly, it went more smooth. Like being a trans student, it went more smoothly than I thought it was going to. I was very worried that like a lot of the classes I did before, like how it was gonna affect everything. But because I came as a physics major from basically right next door, everything they kind of do a lot of like cross registering, so it transferred in pretty smoothly. Like my physics classes transferred in as the like tech electives. So basically, I really only have like I'm gonna finish this degree in 2 years basically. So yeah, I'll be graduating on time. I originally came to college in a 5-year program, so it lines up that it's still the same.
Yeah, and I know I've had class with a lot of transfer students too from Penn State, and all of them say that the education is as good, if not better, than a big school like that. Plus, they like the connection with professors, and yeah, I don't think any of them have had too much trouble getting things count and graduating on time.
I think like it's a good balance too, because I'm taking I do have some sophomore level classes and I also am taking some senior higher level classes at the same time. So it's kind of a good mix because I feel like I get to know a lot more, like more people at the same time.
Cool. A question from Nicholas. How is the social life on and around campus? Is there a lot of things to do around the town? I would say that there were. I can remember, so I had a lot of classes with kids the year above me, and I can remember, and Rich can probably speak to this. I can remember that basically like 4 nights a week, 3 o'clock would roll around and everybody would disappear last year when they all were able to go to bars. I know that you guys are a little young for that, but yeah, there's certainly a lot to do around campus. I don't know if anybody else wants to speak to any of that.
Yeah, it's kind of in a good, it's in a good part where it's kind of near a lot of stuff. And even like if you know people, like I said, like the other school is literally right down the road. So it's kind of a good mix.
Not only with just some of the local things, but another thing you could do, some of the different clubs organize different trips. I mean, maybe not this year because of the Corona stuff, but like they would do a trip to New York City one day that everybody could sign up for. I know like Commuter Council would do things like that. So there's things to do around, and there's also things that like bus trips and stuff that you could take as well in ideal conditions.
Yeah, and I think that there's a club that goes on kayak trips and hikes. There's a lot of places to hike and kayak around here, and we also have a ski club. I've gone on a couple trips with them. There's a couple ski resorts around here. I think Montage Mountain's it's within a half-hour's drive, and they're pretty cheap too. And they take a trip up there quite often. And there's lots of pizza places. There's a movie theater right near campus. Not that you can go do any of that stuff right now, but when things are open, I think the school does $3 movie tickets usually. There's bowling. They do free bowling. I think that they even hosted a concert down on I don't know what it's called, across, there's like a riverfront spot. I think they did a concert there once. So yeah, I mean, the university does a lot to help you find things to do around campus. So we got a question from Colin asking about the workload in math in mechanical engineering. worried about it being too difficult. So what would you guys say about the math workload for an engineer at Wilkes?
You have to go through a placement test at first, and you either get put into pre-calc or calc 1. And then from calc 1, you go to calc 2, and then calc 3, and then diff, and then multivariable calculus, I believe it goes. I
think you
finished,
added one in there.
oh yeah,
I
no
think
calc 3, just
yeah.
multivariable. Okay. I finished last semester all my math. I did excel in math though, but I didn't believe it was too hard. You only take one math course a semester. I mean, you could double up, but that's up to you. But being that you only take one a semester, you can focus on it as much as you want. I didn't think it was too bad. I don't know if anyone else has to add to that one, but.
I'd say my experience in the math department here has been pretty good. A lot of that is related to the professors because they're very open to helping you out. I don't think I've ever had a problem talking to a professor. And they've even helped out some of my friends with engineering work too. So yeah, I think it is for math classes, and diff and multi aren't easy, but I think that looking back on it, it does. They have a good lead up to it. I think if you take them in sequence, it's not terribly, it's not undoable, is what I'd say.
To answer Anthony's question, yes, even if you are, I took AP Calc 1 and 2 in high school, and you still have to take the placement test. Everyone does.
All right. And then I think one last question for our student panel before we move on to the interns in co-op and senior projects. Joseph asked how far the soccer field is.
That's all you brought.
The soccer field is about 5 minutes away. It's right over the bridge. And we just got a new one too. So we got that last year.
Don't they bus you too?
No. Well, the shuttle can take you, but we get bused to like away games. But for practice, we have to drive or take the shuttle.
Yeah, and the shuttle does run because I think the tennis fields are also across the bridge, right? And the football field.
Yeah. Mm-hmm.
And Wilkes has a shuttle that'll take you across the bridge. If you walked, it's probably like a 15-minute walk, 10-minute walk.
Yeah,
I used to ride my bike. I used to ride my bike because that's the commuter parking lot is over there as well. The overflow parking lot. And yeah, so it's a little far, but I think that the shuttle seems pretty convenient. So, and then Matthew asked if there's a club soccer team.
I believe there's intramurals, but they're not doing that right now because of COVID.
So normally, yes.
They have intramural sports. If you guys wanted to just play around, it's not like anything big. It's just to have fun. It's not a competition. Because engineering is hard, and if you do love sports, you could still do that.
Awesome. All right, I think that'll be it for our student panel. I think some of you are staying on for the next segment. So if you are, feel free to, stay on. Those who aren't, thank you for your time and answering all the questions that the students had. So our third segment is going to be on senior projects and co-ops. So I have some slides from I think most of you sent slides in, maybe not our last minute additions. So I'll share my screen here, and this one we're going to give a little bit more time to panelists to talk about their slides. I have them in a particular order. I have them in an order, so we'll just go in order on the slides. But if you guys can, take about 3 to 5 minutes and run us through your co-op experience or your senior project. So here, I'll share my screen. All right, there we go. So the EcoWing guys can go first.
All right, thank you, Spencer. My name's Cameron. I have with me here today Nick Martino, but two other members of our group are Seth Fowler and Jacob Demler. Obviously, we're all seniors. This is our senior project. Our advisor is Dr. Mar. He really helps us through it. If we have any questions regarding the project or like the university's stuff, we can go to him and pretty much get access to whatever we need. So our project's the Eco Wing. We wanted to solve the problem of pickup trucks having very poor gas mileage. And we know that the aerodynamics aren't very great with pickup trucks and they're very boxy and big. So we wanted to utilize like the bed space. Obviously you're not going to be hauling stuff, 24/7. So there's some free space there. So we designed the Eco Wing. You can go to the next slide, please. So we had Seth, one member of our group just modeled a pretty simple pickup truck, and we use those in a simulations. Actually, a program that our advisor, Dr. Gamari, recommended to us. It's called ANSYS Discovery, but it's a free product, but it gives us pretty general results. So we started with about a dozen different designs and shapes and angles and lengths for our wing. You can see it in the top right there. It's just our preliminary design, kind of at the beginning. And then to the left there, you can see our simulations that we ran, and we were actually doing testing in the wind tunnel. So I'm going to hand it over to Nick, and he's going to talk a little bit more about simulations and the testing.
So yeah, as Cameron said, we were doing simulations using ANSYS Discovery Live. We were first using it on our personal computers. Then Wilkes was generous enough to put it onto the computer labs. So we were able to use it on at a bunch of computers at once just to run the simulations. So we could do a bunch of simulations at once and get as much data as we wanted. We recently just started using the wind tunnel downstairs in the basement of Stark. In the video on the bottom right, you can see that we got some smoke going through the wind tunnel. That'll show us the aerodynamics and how the wing would help the truck. Right now, we didn't get to printing the wing, so the wing is not there yet, but that's to be coming up. That's about it.
We did see some good results. Just in the simulations alone, our drag forces are actually dropping with attaching the Eco Wing, so we're headed in the right direction. Does anybody have any questions?
Well, we will we'll do the questions after we get everybody to do their presentations. So
Gotcha.
I can get my computer to go to the next slide.
That was it, yep.
Okay, all right, there we go. So next we'll have the Robo Farm. You guys can give your spiel.
Hi, I'm Alex. I have Justin here with me. Our other two partners are Hannah and John. Our team is the Robo Farm. What we sought out to do was to build a robotic pharmacist, pretty much, that would be implemented in a like a CVS or a Walgreens type environment, not a big industrial environment or in a hospital, but more like your local pharmacy and stuff like that. We want to make a smaller, compact, fully autonomous robotic pharmacist. You can hit a slide. So, I mean, it looks rough, but this is our prototype. Most senior projects are split up into 2 semesters. In the first semester, you'll do your design, like on the left, and on the right, in the second semester, you'll do your prototyping. We pushed our group to do the design and prototyping in the first semester. That way we would have time to make revisions to all our parts and produce a better product through the second semester. So we're in the middle of doing that now. And we just finished up our first round of testing and making our revisions and everything like that. But our idea is to make a fully autonomous 24/7. It'll take pills, caps, and then print pills, caps, pill bottles, labels, and everything like that, and put out a finished product on the other side completely autonomously. So yeah, that's pretty much it. Justin, do you have anything to add?
No, I think you hit the nail on the head.
All right. And then we'll go into some of our co-op experiences. Jonah, if you want to do your presentation.
Yeah, thank you, Spencer. So my name's Jonah Harder. I'm a senior mechanical engineering major here at Wilkes. And 2 summers ago, I did a co-op experience back in Liverpool, New York. That's around Syracuse, if you're familiar with upstate New York. And I worked at a company called C-Speed. They're mainly a software engineering company, but they started branching out and getting into radar technology. And they created a mechanical engineering department, and I helped out the mechanical engineers there. So my main task was to help with prototyping for their new product. It's called a rapid deployment unit. It's pictured in the middle and on the right. So as you can see, it's supposed to be like a portable radar. So in the middle is when it's deployed and working. You see the radar antenna on the top. And then on the right side, you can see how it can be packed all together and towed with a truck. So my main job was to come up with like fixturing, like remote holders, keyboard holders, make everything portable and transportable. And I used a 3D printer on the left. It's a Lulzbot has 6 printer. You can go to the next slide, Spencer. So some of my main projects, first off, you can see on the left, it's a TRN plate mounts. So for this plate here, there were a bunch of electrical components, and they all needed to be mounted onto a board on the bottom. And I needed to go through, find out like where the holes were drilled and fit the fixtures to fit each hole and fit the part, as well as make sure there were no interferences with any of the connections. And while the products were working, nothing would overheat or anything like that. This took me like 1 or 2 weeks just because some of the parts I need to be made out of metal. So I need to reach out to certain suppliers and order parts. So I also got experience with working with vendors and do some interpersonal work. And then my other main project on the right was a MOT box redesign, where I completely redesigned a drawer in one of the compartments of the radar to fit a certain assembly of electrical parts. And I had to redesign the mounting plate in the box chassis. So that also took some, I needed to speak with the vendors about those. And then that was a lot of 3D modeling. And then there's just a lot of problem solving, making sure all the parts fit, nothing interfered, and then putting the whole thing together. It was very hands-on, and I was glad I got to see it all the way through, and it's installed in their current model radar right now. And that was the main thing for my co-op experience.
Awesome. You can go next.
All right, hey guys, I'm Colin Dominic. I'm a mechanical engineering major. I'm a senior at Wilkes. Next, please. All right, so their main field of work is designing and making paper core winders. So what this is they're making the inside of a toilet paper and paper towel roll, and they sell these machines to companies like P&G and other smaller companies like Markile and places that make paper. Next slide. Next one, please. So when I started there, back one.
Sorry, I think there's like a delay here. That's my fault.
You're good. Okay, so when I first started at Ronco, these were three of the main things I was using to help cut metal. It was a sander, a bandsaw, and some wire brushes. And they just had me helping out in the shop when I first started interning there and helping to build the core winders. So this winter, well, I'm sorry, I should have said when I started there. I started interning there 2 summers ago, and then I've been back every winter break and summer. And this winter, they sent me up to Vermont to work at a place called Markel, and they had to redesign their shop. And I helped design this. Well, I designed this monorail system with it's to fit a hoist to lift large paper rolls onto a paper machine. So I didn't actually get to finish this project because right when I finished designing it, we had to come back to school. So another guy took over for me. And then these are the guys I work with. And then the next slide is my boss. And then I got a job there after I graduate. So see how it goes from there. Thank you.
Cool. You look so happy next to your boss.
Yeah.
All right, and then I think Rich has 3 slides to share with you.
Hey guys, I worked at Borton Lawson for the internship credit, and I also worked at another place called MTF Biologics as a process engineer. At Borton Lawson, I went in as an intern. One of the first things that they wanted me to work on was creating a database for some of the commissioning work. And I know, like some other people said earlier in the meeting, they were into like software engineering and programming and things like that. And I never was, but that's something I did get more into once I started into the mechanical engineering program. So when I interviewed with them, they saw this would be a good project for me. So they wanted a streamlined process for field notes. So what I did was I made a database in Access, which is a very simple kind of programming kind of thing. But we were able to go through, make some macros, optimize it for a tablet, and then actually go out and use this for field tests. Can you go to the next one, Spence? You can go to the next slide, Spence. All right, cool. One of the more fun projects that I got to do there was Borton Lawson and Wilkes have some ties where Borton Lawson does some of the design work for different changes to the building that happen at Wilkes. One of the projects that they wanted to do was get updated floor plans of all of the buildings and get room data for each of the rooms. So what I did with this is I started by helping place a bid for the project. So try to cost it out, see how much we think it would be to do all of the scans and creating the floor plans and all. So then a part of it was then to go through and then create all of the floor plans for the 52 buildings that are on campus. To do this, what we did was we had 3D laser scans and photo-based scanning for some of the areas. That's the picture that you could see here. That's one of the dorm rooms. We went through, we scanned the entire thing, and then we took that point cloud model and then we modeled right over that in Revit. And then after that, I learned how to program in Dynamo as well, which is just another programming language that you can use for some AutoCAD platforms like Revit and Civil 3D. And that kind of kept going with the programming part of mechanical engineering as well. And then Spence, we can go to the next one. And then what I'm doing now with them is a little bit of HVAC design. So it deals with ductwork layouts, finding equipment that'll suit certain needs for different clients, documenting existing conditions. So going out into the field and seeing, what kind of units they're using, what kind of ducts are being used, going to pre-construction kickoff. So after you make a design, you meet with the contractors and go through all of your criteria, what the plans are for the building, doing a little bit of modeling in Revit, which is similar to modeling in things like SolidWorks or Autodesk Inventor, some of the things that you do in Dr. Bednar's class. And everybody always asks, like, do you actually use anything that you learn in engineering school when you go to like an engineering company? And for HVAC design specifically, we use a lot of thermodynamic and fluid dynamic calculations. There's actually, there was a heat and mass transfer one that we had the other day because we had to find the dew point in a wall. And that's something that you learn in Gamari's class when you're going through heat and mass transfer. So some of the things that you learn will be used in this case, I like the thermodynamic and fluid mechanics stuff. And that is all for me.
All right. And then I have a slide I'll go over some of my internships. So my first 2 summers, I interned with PennDOT, as much as all of us love PennDOT who live in Pennsylvania. And that was a good experience. They do a lot more civil stuff. So I did learn how to like use like read plans and things like that. And then the next internship that I had was with Borton Lawson, which is where Rich works, where I got to do some similar stuff to what he did with the 3D scanners and some room planning. And I also got to work on some electrical circuits for industrial applications. And then I also interned at Pride Mobility, which is in their test lab. They make electric wheelchairs. So like they have like a little joystick that you can drive them around with. And I worked in their test lab where we did a lot of programming of systems to test longevity of products. And then last summer I interned with P&G making Love's diapers. And as awesome as that sounds, it was actually a blast to do it. P&G is one of the most advanced factories in North America. And they happened to be an hour away from campus. And then I ended up working for them all summer, had a great experience, and they're hiring me to work for them next year. And then I think, Bender, you have a senior project you can walk us through real quick. And
well, it was more for EE 399.
Okay, yeah, then you could walk us through that then. Do you want to give us like a quick, like what you did with, was that a co-op that you were going to talk about?
Yeah, so I worked at Multidimensional Integration. It's a service company for automation. Essentially, I worked a lot with PLCs and coding for PLCs and commissioning. So I've seen the inside of tons of warehouses, like Amazon, Crocs. Funny enough, we actually did do some work with P&G, commissioning their Swiffer wet jet line in Martinsburg, West Virginia. So we do all types of work, and for any like students that are thinking about attending, I mean, the biggest thing to take away from it, from your internship, if you do get one, and you should really try every summer to get one, is just take as much away from it as you can. And you're probably might run into a job or two you don't like, but learn from that, hey, I don't like this, but it narrows down what you do like. So just take advantage of every opportunity you can get.
All right, and then that's all of our presentations. If any of you have any questions, feel free to ask them in the chat. So I think some of you guys touched on this, but I'll start off with one of the questions we have was how much information from class do you use at your co-ops and your internships? So feel free to just chime in.
10%. Use about 10%. The other 90% is a good framework that based on that 10% that I've used personally, but everyone's probably a little bit different.
Yeah, I'd say that for my co-op, it was most of the stuff you do at school is like learning the language of what you're going to talk. And then when you get there, you know, you're never going to be really that great at AutoCAD until you do it every day for an entire summer. So you kind of know the gist of what you're doing. But when you get a job, most places don't need you to be an expert at what software that you're going to use. They want you to sort of know what you're doing. And then when you get there, on-the-job training is like, that's exactly what it is. You do on-the-job training and grow your knowledge from there.
I mean, it's completely okay to not know what you're doing. That happened to me my first time on site. Took me about 3 days to really figure out what I was doing. But just take your time with it. Ask a lot of questions. They're a really good company that's taking you on for the first time. And if you don't really have much experience, they're not going to expect a lot from you. but don't be afraid to take some risks and ask tons of questions. The best engineers you ever meet always ask questions. Find work to do, and I don't mean just like don't find random stuff to do that your boss doesn't want you to do, but continually ask your boss, your manager, your coworkers if they need help with anything, because they're going to look at you more as a team player than anything, and that can really help. And you can also get familiar with your coworkers. You can know other people in other departments. So maybe when you get out, the internship you were in, you didn't like, but you can, hey, I want to try this department out for a couple months and see if I do better. Just take the time to, again, really take everything away from it that you can.
All right. Jonah, I don't know if you had something to add. I saw you unmuted there for a minute.
Oh no, I mean, you kind of covered it pretty well. Like our most engineering curriculums cover like multiple different fields, and usually for your internship, it's just going to focus on one field. And that's just kind of how it is. You just try to find which one suits you and which one you're good at.
Yeah, I know for electrical, there's a very broad base of knowledge in electrical engineering. And then, so you've got all kinds of digital circuits and programming, and then there's power systems and wireless communications and all of that sort of things. And the job I had, the entire job was arc flash analysis with it, which is just analyzing big power in industry, where it's like 480 volts powering a big, huge 500 horsepower motor. So of all the electrical engineering knowledge I had, it's just that one little segment that you could build a career out of.
Did you ever put on an arc flash suit yet?
I haven't put one on, but they look kind of crazy.
It is awful. You're in a hot warehouse in a rubber suit. Just get that mental image in your head.
Have you put one on, Rich?
No, I didn't. I actually did an arc flash analysis with Frank the other day. We had to go down somewhere and
Yeah.
I did not have to wear the suit though. But next meeting, get Frank on this. We'll talk about it for 6 hours.
Yeah, you would. All right, so we have a question from Matthew. How did you find most of these internships, through the school or through outside services? I'd say it's probably half and half. I think a lot of students who are ambitious will apply to every General Electric, Boeing, Lockheed Martin, Northrop Grumman that they can possibly find on the internet. And sometimes those turn into offers. I know I applied for a company called Cirrus Aircraft just because I know about them, and they offered me a position last summer. But then the other half are from the career fair. I know Borton Lawson's at our career fair every year. It's a great company to work for. P&G has started recruiting on campus. Smith Miller's on campus, Pride Mobility's on campus, UGI's on campus, PPL's on campus, and there's tons more. But I would say it's about half and half. The school has a great career services program.
There's a lot of companies that'll reach out to. Like we get an email from some of the engineering secretaries every day of, hey, this person's hiring for a process engineer. Hey, this person's hiring for mechanical engineer, an intern position. So there's plenty of available positions all around.
Yeah, I think just today we got a PPL opportunity last week, and like 3 more from Lisa in the mechanical engineering department, Mitsubishi Chemical, Bryden Beckart. Yeah, there's tons of companies constantly reaching out to Wilkes to try and get students.
Yeah, just cast a wide net and see what you catch, really.
Yeah, and that is the biggest thing. Like, I think you'll find a lot of students, the students who are most successful aren't the ones who are going to rely strictly on the career services department. I think everybody uses the resource, but it certainly helps to have ideas of where you want to work and, put your best foot forward and reach out to as many people as possible. But yeah, Wilkes does a great job of getting students jobs, I think. I think a lot of the kids who graduated last year are in pretty good positions. I know, Rich, are you working at Borton Lawson permanently now?
Yeah, I'm currently full-time Borton Lawson PVT.
Yeah, And again, if you guys have questions, feel free to post them in the chat. Senior projects questions too, feel free to ask those. All right.
Don't forget to follow our Instagram. I'll post it in the chat. We're going to pick 2 people to get t-shirts that we designed last semester with Wilkes Engineering on them. We post our ESAC events there too. So if you want to know upcoming events or what's going on, you could always look at our Instagram.
So one of the questions that we have to ask you guys too is how much work was put into your senior project? I think I would preface that by saying I think that it's a Dr. B quote that your senior projects 1 class is the hardest 1 credit class or most work you'll ever do for 1 credit. But yeah, if you guys want to touch on how much work it's taken for senior projects.
A lot.
Yeah, I think it is the culmination of 4 years of education. So yeah, it's definitely
it's a lot.
Yeah, it's a lot of work, but I know Alex, your team's been working on yours for like 3 years now too, right?
Yeah, it's always been like an idea, and then little by little, you make this part, and then with the comp sci minor, you're always learning how to program, and the whole interface, just comes together. Last semester, I had a project in database management where I made the whole background database that the RoboFarm is gonna rely on. So yeah, it's just too much time.
So I think that's why you guys are so far ahead of everybody else then, huh?
Wow. A lot of hard work, Spence.
Yep.
Spencer, you mentioned me my name. I think I'll refine my quote that you said. I said that getting a 1.0 in a 1 credit class won't affect your GPA. So I can't motivate you with the grade. It has to be something that you want to do and you want to pursue, just like Alex is saying, just like all the other teams were saying. It's going to be something that you're going to put on your resume 10 years from now when you're going for that senior engineering position. Hey, this is that cool thing I made in college. Or, it seemed like a lot of the early chats were, how do we get hands-on? How do we get involved? You've been waiting for 4 years to do this. So, so I think a lot of students just get excited about your project. You're building a brewing system, like how cool is that? That's a home brew system, right?
Yeah.
I kind of like to follow up on Dr. B's statement. I think that in my years of interviewing new employees coming directly out of college, I think the question that we used to ask most often at Lockheed Martin was, what did you do for your senior project and did you have a good time? We wanted to know what you did, how you enjoyed it, how you picked the subject, and the question we asked most often was, what mistakes did you make? Because the ultimate issue in senior projects the students that I get, everybody makes a mistake sometime, and you just have to, things don't go as you plan. And a lot of companies would like to see if you figured out how to make things happen, even though you have obstacles that come up and some things that seem to bother you. So the senior projects, I think that whole capstone concept is a really, really good and a very, very important concept. So I agree with Dr. B that you're going to work harder for 1 and then 2 credits than you work for many 4 credit hour courses, but you get back what you put into it, and you get back actually more than you put into it. It's very worthwhile.
Yeah, and the whole senior projects class is structured around, we have a project management class. So it's not just, hey, build a thing. It's, hey, build a thing, but follow a process that helps you do everything properly and what you're going to have to do when you get a job. So Wilkes is great at training you to become a good engineer for a company to hire. So that brings us to 7:30. I don't see any more questions coming in from the chat. If I'll share my screen one last time. So if you would all, just to see it one last time, please follow our Instagram page. I will be selecting 2 from tonight to send a t-shirt. And then any questions you have about Wilkes or anything, there's 4 emails there for you. So if you'd like to save those for future use. Any questions you have, if you think of anything. I know Olivia said she's the one who's always going to think of something the day after that she forgot to ask today. So yeah, just write down those emails. If you have any questions, you can reach out to us and we'll be glad to answer any questions that you come up with in the next few days. Yeah, I don't have anything else. I think that brings our event to a conclusion.
I'd sure like to put up my words of thanks to everybody, and I sure would like to see you here face to face. When we be able to survive all of these COVID things, come see us. Part of the beautiful part of Wilkes is being here face to face, working together, hands-on in our laboratories and in our classes. And I think that's something that we hope you got a good taste for it. And tonight you can get a feel for the closeness of our students and our faculty. Come join us.
Thank you, everybody. Have a great one.